Hello guys, welcome to IB360. In this video we are going to solve the questions 20 to 30 of IBDP SL 2020 November. Okay, so in the question number 20 it says that there is a mass M that is attached to the end of a string. Okay, so this is the string, and at the end of the string there is the mass capital M. The string is passed through the hollow tube and the small m is attached at the other end. Okay, so this is the hollow tube, and at the end of the hollow tube there is the small m mass that is attached. The friction between the tube and the string is negligible. Okay, so the mass m travels at a constant speed v in a horizontal circle. So this mass m, if you look from above, it will travel in a circle like this. Okay, so this is our mass m and it is actually travel in this circle, okay, with suppose a velocity v. Okay, and this is the string that is attached. So if I just draw the free body diagram, we can get the better view. Okay, so suppose the tension in the string be T. Okay, so the tension in the string is T, which is acting towards the circle. Okay, so what can I write? The summation of net force towards the center of the circle is equal to mass into acceleration of the particle towards the center of the circle. Okay, so what is the force acting towards the center of the circle? Only tension T is acting, right? So T is equal to mass into what is the acceleration of small m towards the circle? Centripetal acceleration, right? V square by capital R. So over here T would be equal to V square by capital R. So from here we get that T is equal to your mv square divided by capital R. Okay, so this completes a free body diagram of the small m part. Okay, but see over here capital M is also balanced, right? So if I just draw the free body diagram of capital M, see, this is capital M, it's balanced, right? It's not moving anywhere. So over here upward will be the same tension T that is acting through the string, right? And downward will be the capital Mg. So from here, if it's in equilibrium, I can write the summation of net force along y-axis is 0. So that means T should be equal to your mg. Okay, so now these tensions are equal, right? Why? Because this is the same string. In the same string, the tensions are always equal provided the string has no mass. Okay, so that means capital Mg is equal to your small m v square by capital R, right? So what do we need to find? Capital M, right? So capital M is mv square divided by R times of G. So that is option number D. So I hope you got the question. I hope you got the question. Now proceeding on to the next question, that is our question number 21. It's an interesting question. So you have been given 4 of the energy states, right? E1, E2, E3 and E4. Okay, and the transition between any 2 states is possible. Okay, so what is the shortest wavelength of the radiation that can be emitted from these 4 states? Okay, so when a particle jumps from one energy state to the other energy state, it releases energy, right? And that energy is given as delta E is equal to your h nu. Okay, so what is nu? Nu is the frequency. Okay, and it can be further reduced as, nu can be written as, that is the frequency can be written as c by lambda, where c is the speed of light and lambda is the wavelength emitted, right? So from here I can write that delta E is equal to your hc by lambda. Okay, so that means lambda, that is the wavelength emitted when the transition is being, so what is lambda? Lambda is the wavelength emitted when there is the transition from one state to the other state, that is one energy state to the other energy state. So this is equal to your hc by delta E. Okay, so now what do we want? We want the shortest wavelength, right? So that means for the shortest wavelength, right, for lambda to be the shortest, delta E should be the maximum, right? So why? Because when the denominator is maximum, the numerator is minimum, right? So that means delta E is maximum. It should be maximum, right? So that means delta E should be maximum, right? Now what is delta E? Delta E is actually your final energy minus of the initial energy, right? So now we want the final energy minus of initial energy to be maximum, right? So where is the maximum? When the particle jumps from E1 to E4, it will have a much larger energy difference, right? Rather than jumping from E1 to E2 or from E1 to E3, right? Because the energy difference between E4 and E1 is the maximum, right? And for shortest wavelength we need maximum change in energy, right? So delta E would be equal to your what? E4. Very good. E4 minus of E1. So lambda from here would be equal to your Hc divided by E4 minus of E1. Okay, I hope you got the question. The answer to this is option number A. So proceeding on to the next question, that is the question number 23. Three historical developments in physics were: 1. Wave particle duality. Yeah, it was a very important historical development in physics. Why? Because the fact that light can be as a wave and the particle simultaneously, okay, so this paved the basis of our quantum mechanics. Okay, so this is a very important development. The kinetic model of gas presides long way back. It's not that much of a historical development in physics. Okay, the third one is the equivalence of mass and energy. Yeah, it's pretty obvious. It's the work of Albert Einstein that energy and mass are equivalent. Okay, and it's paved the way for much more complicated branches of physics. Okay, so that means 1 and 3 will be the correct option, and the option is option number B. Now proceeding on to the next question, the mass of a nuclear fuel in a nuclear reactor decreases at the rate of 8 mg per hour. Okay, so that means the mass, that is the delta m divided by delta t. So this is given to be your 8 mg per hour. So that means 8 milligram per hour. So if I just convert it into SI units, that is kg per second. Okay, so if I just convert it into SI units, so 8 mg is 8 into 10 to the power minus 6 kg, right? Divided by, okay, 1 hour is how much? 3600 seconds. So that means the rate of change of mass delta m divided by delta t is this. Okay, the overall reaction has an efficiency of 50%. So the efficiency it's given in the question to be how much? It's given in the question to be 50%. Okay, what is the maximum power output of the reactor? Okay, so we know that E is equal to mc square from Einstein's equation, right? So what is power? Power is what? Energy by time. So this is equal to your mass by time to c square. Okay, so that means what is the change in mass with respect to time? This is the change in mass with respect to time given in the question. Okay, so that means the power generated would be equal to 8 into 10 to the power minus 6 divided by 3600, okay, into c square. What is c? The speed of light, right? What is the speed of light? 3 into 10 to the power 8, right? Into whole square. Okay, so from here we get that power is equal to your 8 into 10 to the power minus 6 into 9 into 10 to the power 16 divided by your 3600. So from here we get that 72 into 10 to the power 10 divided by 3600. On further calculation we get that this is equal to your 2 into 10 to the power 8. Okay, so what is now we have to convert into megawatt or gigawatt. Okay, so what is 1 megawatt? 1 megawatt is 10 to the power 6 watt. Okay, another thing over here, they are given the efficiency is 50%. Okay, and the power that is produced is this much power. So if the efficiency is 50%, the net power that is produced would be half of that power, original power, right? Because the efficiency is 50%. So the net power that is produced will be equal to 10 to the power 8, okay, watt. Okay, 1 megawatt is equal to 10 to the power 6 watt. Okay, so that means 10 to the power 8 watt is equal to your how much megawatt? 100 megawatt, right? So that means the correct option to this question will be option number A, that is your 100 megawatt. I hope you got the question. Now proceeding on to the question number 25. A nuclear power station contains an alternating current generator. What is the energy transfer performed by the generator? So it's a tricky question, okay? So in this question you have to keep in mind that a generator can be used anywhere, okay? It can be used in a nuclear power facility, and it can be used in household purposes also, okay? So that means you just have to keep in mind that for only a generator, what happens? A generator only converts kinetic energy to electrical energy, right? Rotational kinetic energy to electrical energy, okay? And it can be used anywhere, okay? So this is a trick question. The answer to this question will be equal to option number B, that is rotational kinetic energy to electrical energy. So this is the correct option for question number 25. Now proceeding on to the next question. The average temperature of the surface of the planet is 5 times greater than the average temperature of the surface of its moon, okay? So suppose there are two planets, this is the planet and this is the moon of the planet, and they are given that the surface temperature of the planet, okay, so it's is 5 times greater than the moon. So if the moon temperature is T, so that means the temperature of the planet will be 5T, right? The emissivities of the planet and the moon are the same, so sigma is same for both the planets, okay? So what is the average intensity radiated by the moon, okay, when the average intensity radiated by the planet is I, okay? So they are given that the intensity radiated by the planet is I, okay? So what is I is equal to your sigma E into T to the power 4. That means the temperature to the power 4, okay? What is the temperature? 5T, right? So that means the intensity is actually how much? Is actually 5 to the power 4 T to the power 4 sigma into E. Now what is 5 to the power 4? It's nothing but 625, okay? Sigma E T to the power 4, okay? So now we want to find the intensity by its moon, okay? So suppose the intensity by its moon be I dash. So what is I dash? Sigma E into temperature to the power 4, that is T to the power 4, right? So I dash is what? I dash is sigma E T to the power 4, okay? But we want the answer in the form of I, okay? Very easy actually. So over here, what is sigma E T to the power 4? I by 625. This is equal to your sigma E into T to the power 4, right? So that means from here we get that I dash would be equal to your I by 625. So which is the correct option? So this is not the correct option, okay? So the correct option is option number C. Option number C. So this is the correct option to question number 26. So proceeding on to the next question. A simple pendulum and the spring mass system oscillate with the same time period, okay? So that means what is the time period of a simple pendulum? Simple pendulum time period is, we know that this is 2 pi root over of L by G, okay, where L is the length of the pendulum, okay? And the time period of the spring mass system is what? 2 pi root over of m by k, where m is the mass of the body and k is the spring constant, okay? And they are saying that the time periods are equal, so that means 2 pi, my bad, that is 2 pi root of L by G. So this is in fact equal to 2 pi root over of m by k, okay? So that means from here we get that root of L by G is equal to root of m by k. We get this part, okay? And now the masses are halved. What is the time period of pendulum divided by time period of the spring mass system when the masses have been changed? Okay, so when the mass have been changed, what is the time period of the pendulum? It will still remain the same. Why? Because the time period of the pendulum does not depend upon the mass. It depends upon the length of the pendulum and the value of gravitational acceleration, right? So that means what is the time period of pendulum? 2 pi root of L by G, okay, divided by, okay? What is the time period of the spring mass system? So instead of m over here we'll have 2m, right? So that means 2 pi root over of 2m by k, okay? So from here if we just simplify, from here we'll get that root of L by G divided by root 2 into root of m by k, okay, and these are equal. Okay, root of L by G and root of M by K are equal, so this will be equal to 1 by root 2. So that means the correct option would be equal to your option number A. Why? Because if you just see, root 2 by 2 is nothing but 1 by root 2. Okay, you divide both sides by root 2. Okay, so that means the question number 27, there is option number A. Now proceeding on to the next question, light is incident on a diffraction grating. Okay, the wavelengths of the two spectral lines of light differ by 0.59 nanometer. Okay, so that means delta lambda is given to be in the question to be 0.59 nanometer. Okay, and have a mean average and have a mean wavelength of 590 nanometer, right? So that means lambda is given in the question to be 590 nanometer, which is the mean wavelength. Okay, the spectral lines are resolved into the fourth order of grating, so that means the value of m is given to be 4. Okay, so what is the minimum number of grating lines that were illuminated? Okay, it's very easy. Actually, apply the formula only. Lambda by delta lambda is equal to your m times of n, where n is your number of grating lines. So from here we get that n is equal to your lambda by delta lambda into m, small m, right? So from here we get that lambda, what is lambda? 590 nanometer. Okay, delta lambda is 0.59, okay, into 4. Okay, so from here we get that the value of n, if you just solve this, the value of n will come out to be 250. The correct option to this is option number B. So for 28, correct option is option number B. Now proceeding on to the next question, white light is incident normally on a separate diffraction gratings x and y. Y has a greater number of lines per meter than x. Okay, 3 statements about the differences between x and y are. So they have given 3 statements. Okay, so first of all, from the question we get that y has a greater number of lines per meter than x. So that means n of y is greater than n of x, right? So that means 1 by n of y is less than 1 by n of x, simple inequality. And what is the reciprocal of the diffraction grating, right? What is the reciprocal? This is the distance between the slits, right? So that means the distance between the adjacent slits for y, that is d of y, is less than d of x. Okay, so that means the adjacent slits gratings are farther apart for x than for y. So option number so that means statement number 1 is correct. So for statement number 2, the angle between the red and the blue light in a spectral order is greater in x than in y. Okay, so from the formula we know that d sine theta is equal to your n lambda, right? So that means sine theta is equal to your n lambda by d. Okay, so that means when d increases, sine theta decreases. So when sine theta decreases, theta decreases, right? So that means for x, okay, so for x we have greater separation between the slits. Okay, so that means it will have the smaller angle. Okay, the angle between the red and the blue lights in a spectral order is greater in x than in y. It's wrong. Why? Because in x the d is greater. For d being greater, sine theta will be lesser. So if sine theta is less, theta will be less. Okay, so option number, so that means the statement number 2 is incorrect. Now comes statement number 3. The total number of visible orders is greater for x than in y. Okay, so from this inequality we know that sine theta is equal to your n lambda by d. Okay, so I can write that from here n lambda by d is actually less than equal to 1, right? Why? Because sine theta's value is always less than equal to 1. Okay, so that means from here we get that the number of diffraction gratings n is greater than equal to your d by lambda, right? D by lambda. Okay, so the total number of visible orders is greater for x than for y. Yes, why? Because the distance between the slits, that is d, is greater for x, so that means this will be greater, and lambda is constant, right? So that means the value of n will be greater. Okay, so that means what will happen is that statement number 3 will be also correct. Why? Because for y, see, the distance between the slits is lesser. When the distance between the slits is lesser, the n, that is the number of visible orders, will be also less. Okay, so that means option number B is the correct option. 1 and 3 is only correct. So the correct option to question number 29 is option number B. Now proceeding on to the next question. Two satellites W and X have the same mass. Okay, they have a circular orbit and W is closer to the surface than X. Okay, see, W is closer to the surface of the planet P. Okay, what quantity is smaller for W than for X? Gravitational force from the planet. Okay, so we know that gravitational force is equal to your G m by r square, right? So that means as the radius increases, what happens? The force decreases, right? So see, over here W is much closer to the planet P, right? So that means its radius will be less compared to X, right? So that means when the radius is less, the force will be more. So option number A is incorrect. Okay, angular velocity. Okay, so that means, see, over here for W, okay, so what is the angular momentum of W? M into r1 square into omega. Okay, and what is the angular momentum for X? M into r2 square into omega. Sorry, this is omega 1, this is omega 2. Okay, for the planets that are orbiting around so for the satellites that are orbiting around the planet, angular momentum is always conserved. So that means m r1 square omega 1. So this is equal to m r2 square omega 2. Okay, so that means we want to find omega 1, right? Omega 1 will be equal to r2 square by r1 square into omega 2. Okay, and we know that r2 is greater than r1, right? Why? Because the distance of the satellite X is greater than distance of satellite W. Okay, so that means omega 1 would be greater than omega 2. So angular velocity of W is not smaller than X. In fact, angular velocity of X is greater than W. Okay, orbital speed. What is orbital speed? It's velocity, right? So what is velocity? Velocity is equal to omega into r. Okay, for W, what will be your velocity? For W, V1 would be equal to your omega 1 into R1. And for X, what will be your velocity? V2. This will be equal to your omega 2 into R2. Right? Now, we have to compare between omega 1 R1 and omega 2 R2. Which is greater? Okay. And we know that m R1 square omega 1. So this is equal to your m R2 square into omega 2. Right? From here, that is the angular momentum is conserved. So from here we get that r1 square into omega 1, this is equal to r2 square into omega 2. So from here we get that omega 1 r1 divided by omega 2 r2, it's nothing but is equal to your r1 r2 by r1, right? And what is r2 by r1? R2 is for distance of the satellite X and r1 is the distance of satellite W. Okay, so that means obviously r2 is greater than r1. So from here we get that omega 1 r1 divided by omega 2 r2 is greater than 1, right? So from here we get that omega 1 r1 is greater than omega 2 r2. So that means for this satellite W, what will happen? The velocity, orbital velocity would be greater. Okay, so that means this is also the incorrect option. Now the orbital period. Okay, so the orbital period T, okay, this is equal to your 2 pi r by v, right? That is the speed. So that means the orbital time period is for W, this will be equal to your 2 pi r1 by v, v1. Okay, and the time period for X, this will be equal to your 2 pi r2 by v2, right? Okay, so from here we got that v1 was greater than v2. Okay, so if I just divide this, so it's becoming a little messy. Just a second, hold on. So if I just divide this, the time period of W divided by the time period of X, this will be equal to your R1 by V1 R2 v2. So that means the time period of w by time period of x, this will be equal to r1 by r2 into v2 by v1. Okay, r1 by r2, which is greater? R2 is greater than r1, right? So this ratio is less than 1. And v2 by v1, so from here v2 by v1 is less than 1, right? So this ratio is also less than 1, right? So that means the time period of w by time period of x, since this ratio is less than 1, this ratio is less than 1, the total multiplications ratio will be less than 1, right? So that means what will happen? The time period of w will be less than the time period of x. Okay, so this is the correct option. It's a very good question. It revises all of the important factors of your gravitation chapter. Thank you.